Welcome to the Muxall Open IoT channel. I am your host, Michael Crane. Okay, so in today's video, we are going to be looking at a customer return, and he will remain nameless. I don't want to throw anyone under the bus. We all make mistakes. But anyway, he wired up his Muxall Pro barbecue controller and did something. He did a cook, or he's tried to do a test cook, and he fired off the test cook and then went and ran an errand. By the way, that is not a good idea. I do not recommend plugging in a brand new controller and then leaving it to test by itself. But anyway, he set it for 350, came back, said the grill was off. So anyway, he got me on the horn, and I said, okay, well, let's just turn it on and see what it does. And he turned it on and hit start, and it started smoking. So, and this was after I kind of told him, I said, we need to double check all the wires, make sure everything's plugged in the right spot, and he did that. At least he says he did that, and I believe him. And anyway, and then of course he turned it on, and it smoked. And that's actually, unfortunately, kind of common. I don't get them a lot, but if you're not real careful, you can short out stuff to the back of these controllers. And here is why. All these components right here, these triacs. So this is the auger triac, this is the spare triac for the PHV, this is the fan triac, and the igniter. And see all these little tabs right here? These are all have mains voltage running in them. And I do put conformal coating on them. That helps a little bit. But yeah, if you push any kind of metal up against that, it's going to short it out if it's connected to ground. Also, all these caps are mains voltage. These resistors in here. This fuse, of course, is mains voltage. And I can see that it's been smoked. I'll zoom you guys in here in a second. But my point is, in all these little, legs on the triacs, these are all mains voltage, right? The mains voltage being the power coming from the plugs in your house. And if you short those to ground, you will create a massive amount of smoke and possibly a fire. So you have to be very careful when you're mounting these things inside your grill that none of this stuff touches metal, right? So you need to do some cable management to make sure there's nothing metal, and it's usually wires that can touch any of these components on the back, right? Okay, so enough of the lecture about shorting the back of these guys out. And this is very common. All these barbecue controllers have mains voltage running in the back like this. So yeah, it's not just the Muxall Pro, it's all of them, right? So anyway, enough of the lecture on shorting the back of it out. So anyway, he was on the phone. I said, okay, well, just send it back to me. I'll see if I can resurrect it. And so this is going to be kind of a investigative and maybe repair video. We'll see. All right. So yeah, so let's get started. And the first thing I noticed, let me zoom you guys in here real quick. Oops. Let's see. You guys see that? Yeah, so the first thing I notice is that the fuse has been smoked. So we'll go ahead and remove that guy. He's no good anymore. And he said when I was on the phone with him, he said that it was coming from, the area where the chamber probe plugs into. And I was kind of looking at this guy, and I don't see anything. I kind of looked all over, and I didn't see anything. But what I did see, let's see, let me turn a light on. Maybe I can get some better light in here. There we go. Yeah, so there you go. So you can see this has been smoked. And I was like, uh-oh. He's fried the ESP32. And by the way, I have not applied power to this thing, so we're doing this real time. I don't know what's wrong. I did do a real quick look, and I did see this, but I was baffled. I was like, it looks like it smoked the ESP32 board, and I'm like, well, this is connected to a Wi-Fi, the ground for the Wi-Fi. And if you short the Wi-Fi antenna out, yep, that'll definitely cause problems. But here's the nut on the Wi-Fi antenna, and as you can see, there's not a burn mark 1 on there. Because what will happen, and I've seen it happen before, is this Wi-Fi antenna, the Wi-Fi antenna screws on like that, right? And it is rather close to this tab right here. So this tab is 120 volts AC, and that's bare. So if you get something in there, like a wire or something to short across like that, you will smoke it. And we know that the fuse is blown, so something shorted out. But I was looking, but as you saw on the Wi-Fi antenna, there's nothing there. If you short this to ground, you will see a burn mark. It'll probably blow a hole in it, right? So, so anyway, the Wi-Fi antenna didn't get shorted like that. And I looked at the other end, and yeah, it's okay. So this didn't get shorted anywhere. Yeah. So if you touch this, it will, connect. It'll make the path all the way there through the wire, right? And probably smoke the wire too. But anyway, so the Wi-Fi antenna was good. So I was like, huh, that's kind of interesting. And so another thing that will happen is people will put the chamber probes wires in here, and then when they go to shove it in the grill, the wires, something on the wires or something pushes this down like that, and it will push down and short against, the wires coming out of here will short against something on the high voltage board here. But there's nothing wrong with this. I looked. There is, you can see there's no scorch marks, there's no burn marks. This thing's in good shape. So, yeah, I was scratching my head there for a bit, and I was like, well, what in the world happened to this thing? So I start looking, I'm trying to see, Mr. Fuse did his job. It popped good before it smoked anything on the high voltage board. But you can see this. So this is a, something happened around here. And so I flip it over, and I'm looking at this solder joint, and I'm like, well, it doesn't look very good. And, it should look like this. See? A nice rounded over, well trimmed solder joint. They're all like that. I make these boards, right? I know exactly what they're supposed to look like. And this would never pass. And then I looked at it real close, and let me see if I can zoom you guys in. It looks like it's almost been unsoldered. And then I went, aha, that's what happened. It almost did get unsoldered. I'm surprised this plastic wire here is not melted more. But what happened is a wire shorted against this, and it must have been close enough to this right here. So it was, the wire came in and, I don't know, got shoved down in here. It was close enough to this this hot melt. This hot melt, by the way, this is soldered to the board. The hot melt's there to help stabilize it, because when you start, screwing stuff on it, you don't want to rip it off the board. So anyway, this is just hot melt, and so anyway, the wire touched, and just, probably just heat it up like a like a soldering iron and scorch this, and whatever wire was attached to probably scorched it pretty good too. He didn't give me any information. He just threw this in a box. He's pissed off at me probably. They always do, even though it's never my fault. Well, I shouldn't say it's never my fault, but I personally test every one of these controllers. If you bought a controller from me, I send you the graph. I don't let anything get out of here that I think is something wrong with it. So I know this controller was okay when it left the shop. It could have got damaged, and they can get damaged in shipping, but this right here is obviously got shorted somewhere by a rogue wire. We'll just call it Rogue Wire 1. And so anyway, this doesn't look too bad, so I'm going to go ahead and plug a fuse into it. I might try. So anyway, I think I'll probably plug it into the, let me zoom you guys out. I'll probably plug it into the debug port, make sure the SP32 survived this okay, and if it looks okay, I'll plug in another fuse and test the high voltage and check the high voltage board. So anyway, I will be back. Okay, so I have my, I went ahead and plugged the chamber probe into it. I have my little test slides. You got the auger, the fan, and the igniter kind of plugged in. And yeah, I know it's a bit how you doing, but what can I say? Let's go ahead and turn this guy back on. Uh-oh. This happened last time. I am going to have to revisit these triacs. So, yeah, looks like I'm going to have to replace that triac again. They just do not like being shorted out. And why it keeps being the auger one is just a mind bender. But anyway, yeah, as you can see, that's, let's go ahead and, yeah, I'm going to have to revisit that because the fuse blew. Nothing else seems to be damaged. I don't know, I'm not going to do a whole repair video on it, just replacing the triac. The video I just did is a repair video. If you want to see replacing the triac, you can watch that one. But let me go ahead and start it. Okay, igniter kicked on, fan kicked on, and yeah, that auger's not turning on and off. So yeah, it probably fried the triac. That's what happened last time. Someone shorted one out and it fried the triac. Anyway, yeah, I might have to get a look into buying heavier duty triacs because, I mean, most of the parts on this controller are military grade or medical grade, and but I don't know. I'll have to double check that triac. It should be able to withstand this. I'm not exactly sure why they keep. I mean, I know why they're dying, because they're getting shorted out, and no electronics likes to have things shorted out. But yeah, I would like to think that I have to be real careful because it's still running. But I'd like to think that the triac should. I mean, it's supposed to handle 12 amps. You know, that fuse blows at 5. I would like to think that it should be able to handle whatever spike that was, but I guess it's not. Anyway, I'll replace it, and then we'll do another test. All right. Well, I replaced the triac, and of course everything is hunky-dory. And I also checked the resistors like last time, but yeah, they were all okay. Checked all the traces, everything was good. So yeah, it just for some reason that fuse is not protecting the triac like I want. So I'm gonna have to dig into that a little bit and see why the triac is dying before the fuse blows. So anyway, that has nothing to do with this video. It's just kind of one of those things. I'll probably do another video on the fuses and the triac, and we'll see if we can figure out why the triac is dying when the fuse pops, because we don't really want that to happen. But as you can see, everything's working just fine. You can see the auger going on and off in the background over there. And yeah, so life is good. Okay, so now I'm going to go stick it in the grill, and we're going to do a real field test. Okie dokie, so got it plugged in here. I figured I'd go ahead and video this. Yeah, so when you put it in the grill, you got to make sure that either you don't have any wires getting around the auger fan, you don't have any wires getting up. Let's see, can you see in there? So you make sure that the chamber wire, the chamber probe wire is away from the back. Let's see, is that a better picture? I don't know, maybe. I don't think it's focusing real well. And you definitely don't want any wires touching the back of the controller anywhere. I know this is reflecting really bad, but you kind of get the idea. Anyway, let's go ahead and fire this guy up. All right. Chamber probe is working. Light backlight's working. Let's just hit start. Alright, I can hear the fan. Auger will probably kick on here in a sec. There it goes. And now we'll just have to wait for the igniter. So yeah, I'm going to set it to 225 if you're ever testing a controller for accuracy. 225 is its sweet spot. It should be able to attain and hold 225 very easily where there's something wrong. And if you're looking for accuracy or testing for accuracy, you need to go down to smoke mode here. Oops. And turn on minimum smoke. All right. Okie dokie. Oh, let me go see what the IP address is. Whoops. I can see the smoke coming out of the grill. I don't know if you guys can see that or not. No, you probably see it up there. So the igniter is working and everything looks to be okay. Alright, well, I'm just going to let it sit here. It's about, well, it's about 85 degrees outside. And it is a tad windy out here. I don't know if you can see the trees. So we'll see how well it holds 225. But yeah, I'll check in here and look at the graph here in just a few minutes. Okay, so we're on my desktop here. I pulled up, I'm using Firefox. I always test with Firefox. Let's see, it was 192.168.1.218. Password is Muxall, M-U-X-A-L-L. And wow, looks like it's already gotten to the run state. Oh yeah, 139. Graph. Yeah, sorry this graph is kind of small right now. Everything seems to be running pretty good. So anyway, I'll be back in a few minutes and we'll see how it's done. Okay, so I let it run for a little bit, and as you can see, it started up kind of rough. I was looking at it, I was like, what in the world's going on? I went outside and I had left the lid open. So I closed the lid. You can see that Patsy took over around 1:09 or something like that. And you can see I closed the lid about right here. I was like, uh-oh, this thing is going to shoot to the moon. But yeah, it didn't do too bad. You know, it overshot a little bit and has pretty much been nailing 225 ever since. So I'm going to call this a win and a pass. So anyway, that's about it. If you like this video, give it a big thumbs up. If you have any questions or comments, post them under the video in the comments, and I'll try to answer them the best I can. And I'll see you guys later. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.